Hey there. So, I wanted to talk to you about Metaballs. Once upon a time, I played this game called Spore. It's the neatest thing about this game is how you design the creatures. And if you do it like just Google image search, Spore creature creator, you get pictures of all these creatures. The designer basically works where you place spheres on the screen and you can change the size, you can texture them, you can attach more spheres to the end, and then like slap body parts all over the sphere, and it kind of looks like a creature when you're done. Which is kind of neat. I don't remember how I found this, but one day I was reading and found like the algorithm for building these blobby creatures was based off an older algorithm for metaballs, and it's like one of my favorite demos for this is probably this one. Jurassic.dev marching squares. There's overlap between like marching squares and the, the thing called metaballs. But basically, it's a way of like you're plotting a circle on this grid of floating point numbers, and then there's some math involved in instead of trying to plot a circle directly, which is kind of hard to do. You are interpolating points based off of like you can see over here. It's like 12.2 in the corner, 0.5 next to it, 0.5 above it, and then there's some math involved in interpolating what should be drawn between those points, and you're drawing lines instead of points. And there's rules here like for what lines you should draw based off of the values at each of the corners. And I did a video on this a while back for implementing metaballs and the mini script language. I want to re-implement that same thing in C# for another project that's slowly come together in my mind. Anyway, this is the mini script code. I'll share it on the video description. When did I write this thing? It works okay. You have to keep the resolution pretty high for the language to be able, the interpreter to be able to keep up with it. Grid resolution of 24, like 24 pixels, 24 pixel square grids. But what I basically did is translated all of this code into C#, and we're going to review that next. So, using the same basic framework as the Fire demo I was showing just recently, still building up this retro TK library. It's up there on the GitHub. You can try playing with it if you want to, but don't count on it being stable. I'm just writing it for myself. Entry point is in program. Sets up the command line parameters. Sets up dependency injection. I have a host builder. Load in the app settings file. Tell it how to find the main state. Add the RetroTK library with all of its dependencies. And then we're launching into the main state, which runs asynchronously, whatever that's worth. Actual gameplay is in main state. And we're tracking a couple of things. We have a two-dimensional grid of samples. A list of floats is not the best way to represent this, but I'm just trying to replicate what I wrote in Miniscript a while back. We have a collection of blobs, and we're tracking the mouse, but I don't think we're doing anything with it on this branch. I need to remind myself here. Alright, so in the loading event, we're adding a number of blobs. A configuration object, which is going to be moved into app settings later, that basically represents the constants from the top of the miniscript file. Grid resolution, bumped it down because C# is able to run a bit faster, so we can process more. Some of these just aren't used at all. Don't need it. I'll remove it later. Show grid, true or false. Theoretically, that will draw a grid underneath the metaballs we're going to render. That will show that, like, if you have 8 pixels per grid square, it'll draw an 8 pixel grid. How many blobs we're making, what size can they be, are we interpolating between points? That'll make more sense when we get a little further in. Alright, so we are creating a number of blobs in the loading event. If we go to the blobs create random factory method, we're using those configuration values to calculate a radius and just plopping it somewhere on the screen. Finding some place between 0 and the width and height of the screen that will completely fit the circle. Rendering the grid is fairly basic. The line cases are where it gets a bit more complicated. Get back down there. So one of the things here we're doing here is calculating these samples. This math basically is a translation operation. You want to know how that works? Read over a website like this one that explains it so much better than I could right now. Linear interpolation, that's most of what it's about. Linearly interpolating between 4 points. But we fill the grid with samples. We'll fill the sample grid with values. And then, if we're interpolating, we're trying to do like a smooth connection between the points, which is what this is doing. And I'll show what interpolated versus non-interpolated looks like in just a moment. And then we have 16 different cases, which is all these lines being rendered here. That corresponds to this grid here. See that some of them have no lines being drawn, most have 1, a couple have 2. You see that these 2 are rendering 2 lines, matches this state here, and 1 right here. But if we run this thing, let's take a look. We have our 10 metaballs, and it's it's kind of neat how it's interpolating how to draw that green line based off of how close the balls are to each other. I'm going to turn the grid on and the interpolation on so that we can take a closer look at that. My interpolation is currently on. Let's see, I'm going to turn up the grid resolution. Okay. So interpolation is on, grid resolution is high. We have kind of a blocky outline because of a high grid resolution. The more we bump down the grid resolution, the smoother it will look, and the more processing time it will require. Let's turn off interpolation. And that's even blockier because it's not doing any kind of smooth stepping between the grid points. Let's turn the grid on. And you can see that each point on the outline is either right on an intersection or like perfectly between them. That could have some uses. Been wondering about something like making little asteroids out of metaballs, and then you can have a little spaceship that kind of flies around and shoots at the balls and breaks off chunks, which I think would work pretty well with this algorithm. I might end up going in that direction. So let's turn interpolation back on. And now you can see that instead of stopping at like half grid increments, it's interpolating between the grid points. Looks nicer. Turn the grid resolution back down. And if we bump it all the way to 1, the grid is kind of useless. But you can see it's really smoothly drawn because it's like the grid size is 1 pixel. So it's checking every single pixel on the screen. The benefit we have there is that, turn the grid off and turn interpolation off, because when you are checking every single pixel, interpolating is kind of pointless. But because there's a virtual display here that makes the pixels larger, we can afford more processing time to calculate each pixel because there's not so many of them. If I wanted to bump up the resolution, we would need to probably offload all this to a shader. But we're going to stop this talk here. In the next video, we're going to begin attaching some event handlers to these metaballs and see what we can do with them. So, thanks for joining me, and I hope to see you next time.